So with the law of sines, we are preparing you for answering questions where it's not a right triangle. So take a look at this problem. Can you tell we drew angle C so that it was trying to not be a right triangle? I mean, you could argue maybe C is a right angle, but I hope you can see it's bigger than 90. Okay. So then does anybody remember the name of it if it's not a right triangle? Well, it's actually got two different possibilities. It's either a right triangle, which has got a right angle in it, or it's a, do you remember? Obtuse triangle, which would have how many obtuse angles in it? Think about that. One. The most it could have is one, right? Because if you had two obtuse angles, that'd be two things more than 90, and why is that not possible? You only add up to 180. Okay, so there'd be one obtuse angle in it if it's an obtuse triangle. What about an acute triangle? Well, every triangle has an acute angle in it. So aren't they all acute triangles? No. What if you're an acute triangle? What's that mean? Yes? All the angles are acute. Okay, so in either of those scenarios, it wouldn't be a right triangle, right? Why are right triangles nice? Because you can use normal trig on them. So if this had been a right triangle, and I had told you this side was 5, and this side was, let's say, 6, how would you figure out this last side if it was a right triangle? Everybody please do it. Figure out the last side. Assume for a moment it is a right triangle. Go ahead and figure out the third side in that scenario. I'll pause for a second while you do that. Okay, so there's the fast way and the slow way. All right. The slow way would be to write out a squared plus b squared equals c squared. And then stick in everything you know. A is 5, so it would be 25 plus b squared equals 6 squared, which is 36. Subtract on both sides, take the square root of it. And that would all work. But let me just remind you of the fast way if it was a right triangle. If it's a right triangle, then I go square root of 36 minus 25. You see how fast that is? And how would you know to do that? Well, whenever you are finding the longest side, like the hypotenuse, you would add in there. And as long as you're not finding the longest side, you would subtract in there. All right. So what did you get for your final answer?
It's 3.17.
And it's the square root of what? Square root of 11. 3 point what? 17. Anybody verify that? Uh-oh. 3.32. Is that also square root of 11? Yeah. All right. Can anybody verify that? That's a lot more hands. Okay, good. Must have made a little mistake in your square root. All right. So what's different about this? Well, it's not a right triangle. So how are you supposed to figure out how long that is? Because if it's really not a right triangle, then I could give you one of the angles in here, and you could figure out how long that side is. So I'm going to give you this angle. Would you agree it looks like it could possibly be in the neighborhood of 30 degrees right there? That seem possible?
Yeah.
Okay. So is it a 30, 60, 90? No. The point is it's not. All right. Then we can figure out how long any of the sides are that are left by using this new thing called the law of sines. All right. So everybody write this out. Sine of big A over little a. Now think about that for a second. Look at how big A is the angle. Little a is the side over there. So sine of big A is the angle. We don't know that angle. Well, then I guess I won't use that yet. Equals sine of, and right here, I bet you will know the rest of the formula. Just guess. Tyler, what's your gut? Yep, sine B over little b.
Equals sine C over sine.
Yep. All right. That is a really, really handy formula. Now, would you agree that if I just take part of this formula and I tell you 3 of the things, you'd be able to figure out the 4th one? If you know 3 out of the 4 things, you'll be able to get it, right? So I need to know 3 pieces of info. I can either know the 3 side lengths, or 2 side lengths and an angle, like I have in this problem. And then I just stick them all in the right spots. And I could also use this part of the formula. If I wanted to, I could use this part right here. All I need to do is know 3 out of the 4 parts. So let's put in the stuff that we know. Do we know big A? There's big A and little a. Do we know big A? They did not tell us the angle at big A. So we do not know big A. Do we know little a? Yes. It says right here that it's 5. I'm telling you these are 5 and these are 6 and this is 30. So we know little a is 5, so I'm going to put that right here. I'm going to erase this. I'm going to put in a 5. You need to do this with me because in a moment you're going to be solving this. Then, do we know big B? Patrick, what's big B? 30. So I'm going to replace this big B here with 30. Do we know little b, Jack? Nope. Do we know big C? No, we don't. Okay. Do we know little c? Yes. What is little c?
6.
All right. So then I'm going to put a 6 here. Now, have I got enough info to solve this problem? Which one would you use? Would you use the red boxed one? Would that know 3 out of the 4 pieces of info? Keep in mind, this isn't a letter, it's a number. It's a 6. I'm going to make that a nicer looking 6. Would you know 3 out of the 4 pieces of info in there? No, you wouldn't. Would you know 3 out of the 4 pieces of info in the black box? Nope, you wouldn't. And how about if I did this one equals this one? Would I know 3 out of the 4 pieces of info in there? No. So actually, I don't have enough info to use this formula. I have to use a different formula. This is called the law of sines, server. Why aren't you doing the law of sines? Because the law of sines, I just showed it to you, it wouldn't work for this problem. But there's a different formula that would. And I'm going to teach you that today, even though it's actually tomorrow's stuff, just to show you. The law of sines doesn't like solve everything. It works in certain situations. Would you agree that if I have a box of tools and I take a hammer out, that I can do some things really well with the hammer and other things aren't so good? Like if I want to make a hole in this desk, could I make a hole in the desk with the hammer? Yeah, if I pounded on it long enough, I could probably put a hole in it. Okay, but would it drill way better? Yes. So there's certain times when certain tools work really well. There's another tool called the law of cosines. And I think if we write it down today, then you're more likely to understand it and remember it tomorrow, when tomorrow is all about the law of cosines. All right, so let's write out the law of cosines. A squared plus b squared. You might be like, sir, but that's not the law of cosines. That's the that's the Pythagorean. No, it's the start of the law of cosines. A squared plus b squared. And normally right here you'd say equals c squared, right? But in the law of cosines, you have to go minus 2ab cosine of big C. Notice the big C thing? That's an angle. If it had been a little c, that would have been the side across from that angle. And now it finishes up like you would expect it to in the first place. Take a guess. C squared. So that is called the law of cosines. That's the right tool for the job that we had in the problem that I just gave you. Okay, but I don't want to turn this into the day where I teach you the law of cosines. I wanted to just show it to you quick and show you that the problems that we have today are going to be set up so that the law of sines works well for them. And the problems that we have tomorrow will work well for the things where it's the law of cosines. So the law of cosines works well with a sandwich. I'd write it down. If it's got a side angle sandwich, it's like, hey, it's like you've got this side and you got this side and you got the angle between them. That works well for the law of cosines. The law of cosines can solve that one. So what's the law of sines good for? The law of sines is good when you have an angle and the side across from that angle. Let's look at that for a second. Do you get if I knew A and I knew little a, then I'd know 2 out of the 3 things right there. If I know an angle and the side across from that angle, then I'm really likely to be able to use that formula. I would still need one more piece of info. All right, so I'm going to go over here, and I'd like you to do the same thing. We're going to draw another one of these. Make this angle bigger than 90. And this time we're going to do that scenario where I know this angle is 30. I know the side across from it, and let's say that I say the side across from it is a 4. Now think about this for a second. Is that enough info to figure out everything else? Nope. And I'll give you this guideline. In trig, you always have to have a minimum of 3 things. You have to know at least 2 angles and a side, or 2 sides and an angle. You always have to know 3 things. And sometimes you need more than that, but almost always, if you know 3 things in your triangle, you can figure out everything else. So if this had been a right triangle, if that had been a right angle, then I'd have enough. I'd know, because I know 2 of my angles, and instantly, that means I know all 3 angles. You know what I'm saying? And if I know one more piece of info, like a side, 1 more side length, let's try to keep this about right. If that's a 4, then this can't be an 8. And I want you to think about for a second why it can't be an 8. It can't be an 8. Somebody smart's going to figure this out. Remember, this is not a 90-degree angle. Yes, Alec?
Because 30 doubles is 60 and then 4.
If this was 60 and this was 90, then it would be an 8. Because of the 30, 60, 90 triangle that I had you memorize yesterday. All right, so bottom line, I don't know if you're noticing, there's a lot of geometry in this. Do you get you've really only had 1 course in geometry? For how many of you was that last year? Anyone? Oh, a couple people had it last year. All right, I didn't expect that. How about who had it the year before that? All right. So bottom line, it's been a year and a half. You've forgotten a lot of geometry. So this is one of the reasons why trig is a little more challenging. Okay, so it can't be 8. Because if it was 8, it would have been a 30, 60, 90 triangle. So do you get this angle must be, it looks bigger than 90. Do you get then it must be bigger than 8? So let's say that this side is 9. All right, now you have enough info to use the law of sines that I taught you a minute ago. to figure out, and we could figure out a lot of different things. But let's start. You know what? Figure out anything. And then all the pieces will start falling into place so that you can figure out everything. Like if you figure out one of the angles, you'll be able to get the other angle. And then eventually you'll be able to get that missing side. So I'm going to call this missing side here. Well, what should I call it? Should I call it Q? No, because I'm going to use sine of A over A, sine of B over B, and sine of C over C. So I really should stick to A, B, and C, right? Know what I'm saying? Okay, so let's name these things. And who's already named the 30-degree angle? What'd you name it? Big A. Let's all do that. That way, it'll all, our equations will look the same as the kid next to us. Okay, so let's call that big A. And then what is automatically that forces something else to be called something?
4, 2A.
The 4 has to be little a. And there's a distinction there. Capital A versus a small a. Hope you're getting that. Okay, and then does the 9 have to be the little b? Nope. Could be little c, and it wouldn't matter. So what did you pick for it, Jack, since you started?
I had it as C.
We'll call this one C then. And what does that force everything else to be called? Well, if this is little c, this has to be big C. And if that's big C, this must be big B. And then this must be little b. All right, I would like you to work with your partner, the person right next to you, and use the law of sines. And you can use your calculator to solve this problem. And then if I feel like you guys are getting stuck, I'll jump in and help. Remember, at some point, you're going to have to do like sine of 30. If you don't know how to do that in your calculator yet, I will tell you ahead of time. Try doing it, but if your sine of 30 doesn't come out to 0.5, you're doing it wrong. Okay, so make sure you understand how to put in sine of an angle. But if it does, if your sine of 30 doesn't come out to a half, ask me and I'll show you how to put it in right. Okay? All right, so I hope you started with sine of big A over little a. Sine of big B over little b. And sine of big C over little c. Stick in some numbers. You'll find a proportion. And be like, oh, I can solve that. I got 3 out of the 4 parts. And then solve it. And then keep doing it until you get all of the parts we don't know. Like we don't know the angle C. We don't know angle B. And we don't know little side B. All right? All right, I'll pause for a minute while you work with the person next to you. Okay, you guys keep working. But I'm going to start because if I don't, we will run out of time. You guys keep going on your own. So A is 30, so I'm going to put a 30 here. And little a is 4, so I'm going to put a 4 right there. And I don't have B or little b. Okay, so I'm just going to ignore those two. And I'm going to go right to sine C and little c. Now little c is 9. So I can put a 9 there. Now I'm going to rewrite this thing. Sine 30 over 4 equals sine big C over 9. Sine 30, I told you was going to come out to what again? 0.5, 1/2. Okay, and what is 1/2 divided by 4 over 1? I'm going to flip and multiply them, and that comes out to 1/8 equals sine of big C over 9. What did I teach you about solving stuff? You got to clear the fractions. So I'm going to multiply both sides by 9 times 9, and that's gone. And then sine C is alone. 9/8 equals sine big C. And I heard somebody say it right. How do you solve that then? Jacob. Inverse. So we go inverse sine on both sides. inverse sine cancels, and inverse sine of 9/8. Go ahead and try that and see what happens. You get an error. What does that mean? Yes?
Well, the side of 9 probably has to be longer.
You are correct. That side can't be 9. What? You can't just make up any numbers that you want? Nope. So, what am I preparing you for here? Do you remember this before where we get an answer where there's no solution? Do you remember me saying that in pre-calc a lot of times you get an answer where there's no solution? And that's the right answer here. There is no solution, which means a triangle couldn't be drawn this way. This is called the ambiguous case problem, and you're going to see that about 3 days from now. All right, now I need you to have one that just works out really nice and easy, okay, so that you can all feel that success. All right, so I'd like you to do this problem. And do the sine A over A, and the sine B over B, and the sine C over C. And I usually say big B. You know, the big angle is the one sine goes with. So sine of big A over little a. Sine of big B over little b. This one, I promise, it's going to work out. So a couple things to understand about honors pre-calc. One, a lot of times the answer is that the answer you have doesn't actually work. There's no solution. We like to throw those on the test too. But remember, you have to prove it. So like you'd have to show that it has no solution. You couldn't just cross off all your scribbled problems and say no solution. You got to actually show that there's no solution. And that would have been a good way to show it on our last problem, that you had to do inverse sine of 9/8, which comes out with no solution. So, all right, here. I hope by now somebody has already solved for either A or B. Selena, have you got one of them done? Or not? Okay, so what'd you get? Did you do the sine of big A, which by the way is this one? And I don't know it right off the bat, but if you think for a second, these have to add up to 180, right? So what's A got to be? Yep. So sine of 50 over little a, which we don't know, equals sine of big B, which is got to be this one, and that's 20, over little b, which we don't know, equals sine of, what's that last one? Oh, this must be big C then, and this must be little c. And sine of 110 over little c, which is 5.5. Okay. Now, should I use these two? No, I don't know 3 out of 4 pieces of info. So that one I can't solve. Should I use these two? Do I know 3 out of the 4 pieces of info? Yes, I do. So I can do sine 20. All right, I'm going to give people different tasks. Tyler, I'm going to ask you to do sine 20. Okay. Henry, I'm going to ask you to do sine of 110. Tyler, what'd you get for sine 20?
0.342.
342 over B equals, what was sine of 110?
0.94.
94 over 5.5. Since you've got the 0.94 in your calculator, would you divide that by 5.5 and tell me what you get here?
0.17.
Okay, and then that's all over B. And then I'm going to multiply both sides by B to clear the fraction. And now my 0.342 is going to come into play, and I'm going to divide both sides by the 0.17. I am rounding here, and if you rounded slightly different, you'll get a slightly different answer. Tyler, do you have the final answer? It'd be 0.342 divided by 0.17.
Yes, 2.0
Would you agree that with rounding, that could possibly just be 2? Raise your hand if you got an answer of about 2. Okay, awesome. Do you get that this is all about sticking numbers in a formula, knowing how to put sine of 20 into your calculator, or knowing how to do inverse sine to solve one of those? So if you end up with one of these, like sine of theta equals 1/2, you have to be able to go, oh yeah, inverse sine on both sides. This is going to come up for sure as you do some homework on this. Inverse sine on both sides. Theta equals inverse sine of 1/2. I'm not saying this is the answer to our question. I'm saying be prepared to do inverse sines too, because sometimes you have to solve for an angle. All right, now let's look at some of the homework problems. Actually, this is not a homework problem. It's a problem we can do in class, but let's just talk about how you'd set it up. You always do the same thing. If you've got an angle and the side across from that angle. Now, you might think at first glance, I don't have an angle and a side across from it, but you kind of do. What would the first thing be? Isaac, what do you think we should do first? Super simple.
I guess we would put sin 75 over 200
Okay, why 75?
because that angle is equal to 180 minus 105.
So in other words, you just pick the angle that would make it add up to 180, right? Good. So, just verifying you, 80. Yep, that's right. That's right. So it's got to be 75. So now sine of 75 over 200. The angle and the side across from it become the key thing, because that's got 2 out of the 3 parts. Now, do I really have to write out the whole rest of the formula? No, I can just pick the part that I like. I got big A. I know big A. I'm going to go do that one. Sine of 40 over little a, and cool, I can solve for little a that way. What I'm trying to say here is, you don't have to be a slave to writing out sine A over little a, sine B over little b, sine C over little c. Because, I don't know if you've noticed yet, but you never have enough info to put all the stuff in the formula. Only one part of the formula is going to work. You're only going to know 3 out of 4 parts of either the left side of the formula or the right side of the formula. So you don't have to write out the whole formula. Just get the part where you have 3 out of 4 parts, and then you can solve. All right, move on. More homework. This is actually where the homework starts. And you should get used to a couple things that they do that are kind of weird in the homework. It looks close enough. I think you can understand that that's supposed to be a what? A B. Now, can you tell if it's supposed to be a big B or a little b? Yeah, if you think. Is that supposed to be a big B? Or is that supposed to be a little b? Because it's a degree, you can tell it's supposed to be a what? A big B. Okay? That is not a normal A. Who knows what it is? Say it if you know it. Yeah, it's an angle, but it's... What letter is that? You know the Greek letters at all? That's alpha. What do you think it probably is? An A. So then is it a big A or a little a? You can't just say A. Is it a big A or a little a? It's got to be a big A because it's an angle. All right, you see what I'm saying? So they're going to sometimes throw in alpha, beta, and even later on the screen, it won't be just A's and B's. What do you think is the other letter? Alpha, beta, and, well, A, B, and C, right? So let's go to the next page. We still only have alphas and betas here, so that's not that bad. I can tell that's an A, but it's got to be a big A because it's the angle. Well, eventually they're going to get into the unknown letter, the letter you've never seen before, and that one's a C. Okay, so if it's not an A is alpha. The beta one is like a B. And there's one more that's going to look like a C. Now, for some people, let's get to problem 9 here, for example. They're like, how the heck am I supposed to set that up? I strongly recommend drawing the triangle, so let's draw one. Well, how big should the angle be? About 70. You know that's a little less than 90, right? So I'm going to go like that. And it's alpha, so I'm going to call it A. And it's 68.7 degrees. Next, little a is 70. So I know the side across from it is 70. And little b is 90. Well, where's the b? This is little a. Where's the b? Well, it could be either one. But I'm going to look at this and say, of the how I drew my triangle, what feels like it could be 90? I'm going to say that one feels like it could be 90. So I'm going to call that one little b, which makes this one big B. And that forces the last one to be C. And that makes this side over here little c. Always draw your triangles. If you try to do this just in your head, oh my gosh, you'll get so confused. Okay, so there's my tips for you for today. You've learned the law of sines. You got exposed to the law of cosines. You know it's going to be all about using your calculator to figure out like sine of 23 degrees. You got to know how to do that. And inverse sines or cosines. But usually in this problem today, it's called law of sines. So you're going to do a lot of inverse sine to find angles. Don't forget, if you just brought your calculator for the first time today, make sure you're in mode degrees. It won't like change itself overnight. But if your calculator ever shuts off or you put in new batteries, it'll change back to radians mode, which can be so confusing. So make sure you're in degree mode. Okay, that's all I got for you for today.